50% of the teacher's desk is covered in exams. What is the probability of spilling coffee on one of them? Half and half. You get it? You put that in coffee, 50%. Anyways, so let's go on to some probability rules. The first of the three rules for working with probability is make a picture, make a picture, make a picture. So we're always doing that. And let's go ahead and start with the picture. This one is showing you a Venn diagram, which is very helpful. And here I have a Venn diagram of rough estimate of Cedar Ridge sophomores enrolled in math at Cedar Ridge. Now, this only includes geometry and algebra 2. So you're like, oh, what are these other 47 sophomores doing? Well, they could be in pre-cal. They could be in my AP stats class. Some of them are. They could be in Calc AB, believe it or not. Or they could be in any other different math class. So there's 676 sophomores. This is from the year I looked at it. Can we use the same formula from last time to find the probability that a Cedar Ridge sophomore is in geometry or algebra 2? So the formula was we just add them, right? And we kind of visited this in our classwork. We said, well, wait a second. Do I add the 452? Because there's actually, there are 475 kids in geometry. That's how you read this. If I have a circle of kids, and I say stand in this geometry circle if you're taking geometry, and stand in the algebra 2 circle if you're taking algebra 2, there are actually some sophomores right now who are taking both so they can kind of accelerate and get their calculus in high school instead of waiting for college. So how do we deal with the double counting that's going on there? So we revise the general addition rule. So instead of just saying probability of A or B equals probability of A plus probability of B, we subtract out the double counting. So in this example, if I were to look at it, I would say, okay, the probability of geometry, they're 477, that's 0.703%, 0.703 or 70.3%. The probability for algebra 2 is these 23 plus 154 over 676. And then the probability of both is 23 out of 676, or 0.0304. So if I had the decimal values, I could figure this out from the Venn diagram as it is. But if I just gave you these decimal values without the Venn diagram, you could actually put them into the formula, add the probability of geometry, plus the probability of algebra 2, subtract out the overlap, and you get the same answer that you would get if you just said, oh, let me count these and divide by the total. So here's another example. One card is drawn from a deck of cards. What is the probability that it's an ace or a red? So we'll do this strictly from the formula, and then we'll look at a Venn diagram. So the probability that it's an ace or a red, so I want probability of an ace plus probability of a red minus the overlap. Well, the probability of an ace is 4 out of 52. There are 26 out of 52 red cards, and I subtract the 2 out of 52 aces, which gives me 28 over 52. Now let's go ahead and revisit this with a picture. So I'm going to have ace, I'm going to have red. Well, it's always easier when I'm doing these Venn diagrams to start with the middle. How many of these are both aces and red? There are 2 red aces. I have 2 aces left over, and then I have 26 minus 2, or 24 red cards left over. And of course, if you wanted to figure out this part, this is the 26 black cards left over minus those 2 aces. So if I were to ask you what's the probability of an ace or a red, there's 2, 2, 24. That's 28 out of 52. The same thing as you get with the formula. So you can use the formula. You can draw a picture. I strongly recommend drawing pictures because sometimes we get lost in the numbers of the formulas.